So what is the domain of these functions here? So we have exercise 1. They give you these graphs. These are log graphs. We've seen these. We did them in lesson 49 where you have some logs. So here's a log base 2 of x, a log base 5 of x, and then a log of x, which is a base 10, so log base 10 of x. And you can see the difference between them. The log base 10 of x is pretty flat. The log base 5 of x goes a little bit higher here, and then the log base 2 of x goes up a little bit higher as well, but they all pretty much flatten off and go to infinity, right? So what is the domain of these functions? Well, the domain is how far left and right we're going, and you could tell that these functions do not cross the x-axis, so they don't go past 0 to the left. When you're talking about left and right, they don't go past 0. All right, so 0 is the left part of the domain there. So we're going to say, oh, what happened there? We need a pen. We need a pen. We need a pen. All right, so we're going to say 0 to infinity for our domain, because obviously it goes forever to the right. All right, so we go forever to the right. Now we need the y-intercepts. Okay, so the y-intercept, what are the y-intercepts? Well, if it doesn't hit the y-axis, then that means there are no y-intercepts. So we'll say none there. They didn't ask about the x-intercepts, but x-intercept, the x-intercept is 1. For all these graphs, the x-intercept is 1. Hopefully you're starting to notice that with our logs. Maybe you noticed that already. The behavior of the function as x approaches 0. So that's our end behavior. End behavior used to be x to a negative infinity and then to infinity, but this actually doesn't go to negative infinity. It goes to 0, right? It goes to 0. So as x goes to 0, what does the y do? Well, y goes down forever, so y goes to negative infinity. So we're going to put as x goes to 0, y approaches negative infinity, and then as x approaches infinity, so as x goes this way, what's it doing? Well, it's going to infinity. It's going slow, but it is going slowly to infinity. So the end behavior would be y approaches infinity. And again, we've done end behavior for other types of functions. Now we're just looking at it for these log functions. What's the range? Well, it does go down forever and up forever, so our range is going to be negative infinity to infinity. And we did do domain and range in our last lesson video, so this is, again, just review. Does this function have any relative max or min? And no, it doesn't. No, and we'll put just it's continuously increasing. Continuously running out of room here, increasing. I can't write with this new pen tool. Okay, so let's go on to our next exercise here. So here's graphs, and now more log graphs. Now they're going down, right? And the difference is, instead of 10, 2, and 3, we have 1/10 as a base, 1/2, and 1/3. Okay, I think that's a 3, or 1/2. 1/5. I don't know, whatever that is. But it's 1 over, right? So that you could tell that kind of flips it over. So what happens? These functions are reflections compared to the last exercise over what? Reflections over the x-axis. You probably noticed that immediately. Okay, these are reflections over the x-axis from our first exercise. All right, on to exercise 3. The graph of function f is shown below. Sketch the graph of its inverse. So to do this graph of the inverse, remember we did this in our last lesson. In fact, this was one of your group work problems. You had to find points along here and then flip the x's and y's. Remember, inverse is switch x and y. So here we go. This looks like the point, like 0.250. So we're going to go 0.25, which is right there-ish. Okay, and then let's see, 1, where does 1 hit? 1, 2. Hits about 1, 2. So how about 2, 1? We're just estimating, right? 2 hits like 3-ish, a little under 3. So a little under 3 is going to hit 2. And 4, let's see, 3 hits like 3.5, how about 4? 4 hits 4-ish. So 4, 4. All right, so that's going to be the same. So it looks like it's doing something like, and it's very difficult with this pen. Oh, I almost had it. Looks like it's doing something like that. Okay, and again, that makes sense because they're inverses, which are reflections over the y equals x line. If we draw the y equals x line, I'm just going to do it in red. The y equals x line is when all the x's and y's are equal to each other. So that's the point 1, 1, 2, 2, 3, 3, 4, 4. That's this line right here. And I know we've done this before. That y equals x line is that line right there. So you should see the reflection over that line. That is the inverse. So that shows how these are inverses. Explain how you made your sketch. We'll just go over here. We switched x and y from the given function, right? Okay. The function f graphed above is the function this. So this right here. Oh. Find a formula for the inverse of the function. So we're going to do the inverse of this guy here, which we did a little bit in our last lesson, but now we're going to have with a little +2 at the end there. So let's see how this is done. So y equals log base 2 of x plus 2. So again, switch x and y. We did this in lesson 49, but we didn't do it with a +2 there. So I'm going to change colors here, and I'm going to go green. We'll go Christmas, right? So this is going to be x equals log base 2 of y plus 2. So now I'm going to add that, or subtract that 2 to the other side. Subtract that 2 over there. So I'm going to get x minus 2 equals log base 2 of y. And now convert to exponential form. We know that's going to be the inverse. Base 2. Base 2. Here's my exponent. Logs equal exponents. 2 raised to the x minus 2 equals y. So function inverse, we'll call it f inverse. F to the negative 1. Remember, that means f inverse. F to the negative 1 is 2 to the x minus 2. 2 to the x minus 2. That would be our inverse function. So again, switch x and y, get the log by itself, convert it to exponential form. All right, and exercise 4, domain and range. So now the only difference here is we have a little shift going on. This actually is asymptote of 1. It's kind of difficult to see in this graph. It's meant to be an asymptote of 1. See how this is +1? That means shift up 1. We've done a little bit with shifting, and that's really what we're going to be getting into in this lesson. You see the shift of 1? That means up 1 unit. So my domain doesn't change. My domain is still negative infinity to infinity. Okay, but my range changes. Instead of 0 to infinity, it's 1 to infinity. So my range is 1, infinity. Sketch the inverse function. So that's just, we've done a bunch of those, right? Just get my, erase this here. So do the inverse. So it hits what? 0, 2. So it's going to hit 2, 0. It hits 1. It hits 2, 4. So it's going to hit 4, 2. It hits, and then it just I'm just going to estimate this. It's riding along an asymptote. So the asymptote's going to be 1. It's going to do something like that, right? Okay, something like that. I might have went up too far. More like that. All right, but you can kind of tell by now that the exponential will be the reflection over see the y equals x line drawn there, reflect over that, and you get your log function. What type of function do you expect g to be? Well, we expect it to be a log function. Okay, and what are the domain and range of g? Well, again, when you do an inverse, the x's and the y's switch, so therefore the domain and the ranges switch. So here your domain will be 1 to infinity, and then your range will be negative infinity to infinity. Again, you switch the x's and y's, so your log's going to have the opposite domain and range from the exponential. Find a formula for g. So we're just going to take y equals 2 to the x plus 1. Y equals 2 to the x plus 1. That was our original. So now we're going to make it, we're going to change colors and make it x equals 2 to the y plus 1. Subtract our 1 over. We get x minus 1 equals 2 to the y. And now put it in log form. Log base 2 of x minus 1 equals y. And of course we'll call it g. They're calling the inverse g. So g equals log base 2 of x minus 1. They're just calling it g. The original function was f. They're calling the inverse g. As long as that's defined, you're okay. I equals e to the x minus 5. All right, so we're going to change that to, change colors. Let's change that to x equals e to the y minus 5. And I need a log right away because I got to get that y minus 5 out of the exponent. So we're going to do log base e. Now, instead of writing log base e, we by now know that that is natural log, right? Hopefully you're listening. Natural log of x equals y minus 5 equals the exponent. Remember, log equals the exponent. There's my exponent. In exponential form, this is the exponent. Log equals exponent. And now how do I get y by itself? Add 5. Okay, so my final answer will be y equals ln of x plus 5. So that's my natural log function shifted up 5 units. And we're going to write it as f inverse. F inverse equals natural log of x plus 5. So that really is the proper way to write an inverse. All right, this one's tricky. Pay close attention here. So we're going to have y equals 5 plus x over 6 minus 2x. So that's going to be, switching colors, that's going to be x equals 5 plus y over 6 minus 2y. The problem here is we got these y's in a couple different spots. So we need our common denominator, 6 minus 2y. Whatever you do to the bottom, you do to the top. Okay. That way we get rid of our denominator. So now we got 6x minus 2xy equals 5 plus y. We want to get all our y's on the same side of the equation, so I'm going to add 2xy and subtract 5. That's 6x minus 5 equals y plus 2xy. Adding that to the other side. Now I need to factor out a y. This is kind of different than anything else we've done. I need to factor out my y, and I get 2x, 1 plus 2x. And now I can get y by itself by dividing by 1 plus 2x. And of course, 1 plus 2x is the same as 2x plus 1. I'm just going to divide by 2x plus 1, and there's my inverse. F inverse equals, right here. Oops, no, right here. 6x minus 5 over 2x plus 1. Go back and watch that one again if you didn't quite pick that up. That was tricky. That's tricky. I don't think you'll have to do anything like that, but we're doing it just in case. See you in class.